All right. I think we are live. I'm gonna pretend like we're live. I can't unfortunately see who's out there with me hanging out, but I wanted to welcome everyone to Kong Builders. So those who don't know me, my name is Cody De Arkland. I work for Kong. Obviously, it'd be super weird if I was doing a live stream for Kong but not working here. I've got a couple of great folks helping me out with this to make this possible today. So Taran with our developer marketing team is helping run the show, and then Michael Heap. Michael Heap recently joined Kong. He leads up our developer relations team. So he's a great guy. You'll see a lot of stuff coming out from his team in the near future. They got some really cool plans for what they're going to be doing. We work pretty closely together. So let's talk about why we're here. Obviously, I'm not sharing anything on the screen yet. In a few minutes, my look will go from here to here, and we'll jump into actually building some things. Again, my name's Cody. I joined Kong because I think that we have a really cool way of connecting applications across an entire environment. I'm an application guy by nature. I'm an infrastructure guy, but I really enjoy the way we connect and we make applications run better in an environment. And something I really wanted to do was do a live stream where we go through and we build service mesh from the ground up. So we talk about service mesh a lot, and it happens in the industry. So I try to make this as non-vendor specific as possible. A lot of us talk about service mesh, but we've had a hard time getting it to a place where it's adoptable by people. And I'm not saying installable in the enterprise. That's a whole other conversation. But where people understand the technology in a way that they can use it and do things with it. I think it's a technology that's far ahead of its time. And hopefully, as we go through the stream, you'll start to figure that out too, and you'll see it on the journey as well. So we're going to jump in here in a few moments, and we're going to build from the ground up. This stream is going to be a little bit different than the future ones. In the future ones, we're going to start building applications. We're going to be in and out of VS Code, like actually configuring things, building code, pushing code up into Docker, running containers, stuff like that. In this stream, we're going to do the initial installation of Kuma, the open source service mesh. We'll unpack a little bit more about Kuma in a moment. We're going to do that initial install, and we're going to use my demo app to talk through some concepts. I really want to build the foundation of what service mesh is and how it works before we start doing complex stuff down the road. So talking a little bit about Kuma and what Kuma is. Kuma is an open source service mesh that was developed by Kong and donated to the CNCF. So it's the only service mesh in the CNCF that's Envoy based. So we use Envoy as a sidecar. This is an important term that's going to come up later. We'll dive into it and show some visuals around it as we get through to help it understand. But you can think of a sidecar as a thing that sits alongside your application. Notice I didn't say container. Sidecars are most commonly in containers, but there are sidecar processes that'll run alongside a virtual machine, as an example. And these sidecars, in the case of a service mesh, allow communication between other sidecars. So they act as this proxy layer that allows communication to happen. Why do we do this in the sidecar? Because it lets us bring a bunch of new functionality on top of what that application's already doing. Right. So in the case of Kuma and Kong Mesh is the enterprise version of Kuma. We get to bring in things like observability out of the box, which is a really fancy marketing term. But what that means is I can get a lot of good metrics around what the application is doing. We make it really easy to get Grafana, Prometheus, Jaeger up and running. We're going to step through that stuff in a later stream. We can control traffic policy a lot better. So what we can do is something, my favorite service mesh demo is being able to control the way you roll out a new application and split traffic between the old version and the new version. So you're gradually rolling this out. James Governor at Redmond talks about this in the concept of progressive delivery. It's kind of my favorite thing about service mesh is that we make the ability to progressively deliver applications so much easier. So let's table all that for a second. Let's get in and start playing with some code, looking at the docs. Again, I want this to be interactive. I've got a great team helping me out. I introduced them already. Fire questions, ask things about service mesh, anything you want. I want this to be an open forum. If you want to ask questions about other service meshes, you can do that. Anyone who knows me in the community knows that I don't get uber competitive. I like to talk about technology. I like to teach people. It's my favorite thing in the whole world is to watch people figure this stuff out and get their own ideas as we build together. So if you have questions about anything service mesh related, drop them in the chat. Taran and Michael will do their best to flag them to me as I'm diving in. I can see the chat going a little bit crazy, but I can't click into it right now. So we are going to kick in and start looking around. So I'm going to fire up my sharing. I had a little bit of a monitor issue this morning, so unfortunately, I get the joy of doing a live stream on a single monitor, which is not optimal. Unfortunately, we can fix this at another date. All right, so out of the gate, let's go ahead and head over to the Kuma website. And we rev this website. We update this website as new versions come out. Pro tip: in a week from now, we'll be doing another one of these live streams. Actually, next Wednesday or Thursday, we'll be doing a live stream around the next Kuma release. So we'll be releasing a new version of Kuma with some really cool new features. So we'll be doing another Kong Builders session then, where we dive into that new release and play with some of the new features that are coming out. So that's pretty exciting. If we want to go into getting started, this is the best place to obviously get started. It's funny enough when I look back at how I ended up at Kong, this was probably one of the biggest things that brought me to Kong was this page. Because when I went in and started looking at Kuma and I saw all of the different platforms that we support, I thought that was a pretty cool thing. The ability to run this across a number of environments. We could run this on virtual machines. We have ECS, so we've had an ECS provider for quite a while now. I think it was a little around a year. I know Bart's out there in the chat. So Bart, if you drop in the chat how long we've had ECS off the top of your head, that'd be cool. We use Helm. There's an interesting distinction here between Helm versus Kubernetes. The Kubernetes deployment uses just the Kuma control binary, which I'm going to show here in a few, to actually just do a regular old install. Helm lets you get a lot more customized in it, so we can start to bring in the different configurations for maybe if you want to expose a load balancer for the admin portal as an example, or if you want to control the amount of replicas. The Helm deployment lets you get very specific in the way that the control plane is configured, and I'll take a look at that here in a few as well. So we'll jump in first to the Kubernetes deployment. What this is going to do is it's going to give us the most updated Kuma control binaries. Kuma control is our kind of process, or it's a command line binary that lets you do things inside of Kuma. So we'll go ahead and grab this. I'll switch back into my terminal window. We're going to be working a lot in this repo that I have because I'm relatively new to Kong. My GitHub access hasn't been fully squared away yet, so Michael's going to help me get an actual repo set up on Kong's GitHub that we can properly share out the notes from these sessions on. So for right now, if Taran, if you wouldn't mind posting the link to that repo so people can see it. This is the repo I'm going to be using today. We pop in here and see the stuff that's in this directory. This is on GitHub. You can pull it down if you want. I'm going to go ahead and pull it up in VS Code. And what this directory actually has is the actual application. So the application I'm going to deploy today is a 5-tier application. It's got a web front end. It's got a post and a user service. It's got a database tier, and it also runs Redis because you can't do any demo without a Redis tier. It's kind of a mandatory thing for demos. That's a joke. I've also got some Insomnia API stuff in there. We're going to play in Insomnia a little bit as we go through and do stuff in the meshy world. Yeah, and then I also have Kick in there as well. If we go in and take a look at the actual YAML for deploying this, we can see kind of the overall topology of my application. I won't dive too far into the YAML yet. We'll get into this soon enough, but just wanted to show you that this is an actual application that's going to deploy. You can see this in the repo. I think the repo is a little ways behind, so I'll need to push an update into there. Put my bearings here. Cool. All right. And oops, sorry guys. I know the screen sliding is not the best experience. Let's go ahead and get started with the binary for Kuma control. So what this does is this pulls down the most recent package. When we read to the new version of Kuma, if you run this command again, it'll pull down the binary again for the new version. I have it installed on my system already, but I have Kong Mesh installed. Kong Mesh being the enterprise version is a little different. I want to start off with the open source because I want, as you guys go through this, to be able to do it yourselves as well, to be able to pull down Kuma, do an install, and run through this. Kong Mesh does have a 5 license kind of grace period. It gives you 5 licenses, and I think it's either 30 or 60 days to run inside an environment before before the license goes away, and then you can't run anything. So in the short term, we'll use Kuma and we'll play in the open source one. There's a couple of features that are missing in there are a couple of features that are missing in versus the enterprise version. A couple of things like external cert authority. So if you want to run like a HashiCorp Vault for the MTLS certificates, that's possible in the enterprise version. And then we also have a really, really cool open policy agent integration in the enterprise version that lets you do open policy agent policies as part of deployments, which is really cool. So I've got Kuma here, Kuma 1.6. I go in, oops. All right, so let's take a look at a couple of the things that are in this directory before we do the install itself. We got Core DNS and Envoy here. These are kind of helpers that go along with what we're doing. We run Envoy obviously as our sidecar process. We use Envoy because it's an open source tool that has a ton of development behind it. It lets us focus on building kind of the best darn service mesh we can, while letting the Envoy team focus on making Envoy better. We commit back in any changes or any needs into Envoy. We have a really good relationship with Matt Klein and the team to, live in that open source community and help build against Envoy as needed. So we include that in the package or in our kind of repository as part of the package. Core DNS is used as a part of Kuma as well, mostly for the universal deployment. Universal deployment is on virtual machines versus like the Kubernetes standard, like containerized deployment. So Kuma CP is our control plane process. So if we're running this on a virtual machine, you run Kuma CP. If you're going to run a virtual machine or run it as a control plane, this is a good time to talk about control plane versus data plane. Control plane is the management tier, so to speak, of a service mesh. So when you work with the API or you push policy, that's a control plane operation. The control plane feeds configuration data down to a data plane. That's what that Kuma DP process is. The data plane is that sidecar I talked about earlier. So a data plane lives alongside your application. Data planes register themselves with a control plane. So as administrators of the system, when we go and build a service mesh for our customers, for our people inside of an environment, we are standing up the control plane. When developers deploy their application against service mesh, they are deploying their application and getting a data plane alongside it. That data plane communicates back and forth with the service mesh control plane to receive configuration data. Getting a little deeper, that happens over a process called XDS. So XDS pushes those configuration changes down to the Envoy instances in an environment. These sidecars or data planes receive configurations across the entire environment. So whenever I make a new policy change, that pushes down to the sidecar receives that. This is an important distinction because we talk a lot about running in a decentralized way. This is one of those kind of buzzwordy terms that pops out all the time, and I'm not sure that anyone's ever really taken the time to explain what that really means in the context of service mesh. So when we think of decentralized, the control plane itself, the actual functionality is a centralized control plane. But what it's doing is it's taking its configurations and the things that you're doing and pushing into it and sending it down to all of those sidecars, envoys, data plane instances. Because they're receiving those configurations and all of them are receiving them, that configuration has now become decentralized. Every one of those Envoy instances knows the full configuration of the service mesh. So they can receive, they can act on their policies locally. They don't have to go back and check in for like a traffic permission, for example. If we're saying a front end can talk to a back end, it doesn't have to say, the front end doesn't have to reach out to the control plane and say, hey, am I allowed to make this communication? Am I allowed to reach out to the back end? It knows its communication protocol and its permissions locally inside of its Envoy instance. So it's running decentralized. This becomes really powerful when we start to talk about like load balancing as an example. So I came from the enterprise. I'm used to like living in this world where I have these massive load balancers that live inside of my environment. And they act as like the centralized place for configuring load balancer information. But if like the load balancer goes down, somebody trips over the cord in the data center, that load balancer is offline. All the VIPs, the virtual IPs that host apps, those are down too. No one's getting to the applications. Hopefully you've set up HA in some way, but if somebody trips over the whole power cord for the whole data center, your load balancers are offline. In the case of like an Envoy situation where we're using this decentralized approach and this decentralized load balancing, they're able to evaluate locally, hey, what other instances are nearby? What's the address for those instances? How can I reach them? And that load balancing functionality still works. There's a lot more to that concept that's worth unpacking in future videos, but that decentralized approach to our data plane is one of the things that makes service mesh across the industry such a powerful tool and such a powerful functionality. So if you're setting up a new service mesh on virtual machine, you're going to use this binary here to run the control plane process. And then for every application you deploy, you're going to run this data plane process as well. Kuma Prometheus SD is a tool to help get metrics from a universal deployment into Prometheus. So it lets us have that consistent observability experience, consistent metrics experience between both virtual machines and Kubernetes clusters. Full disclosure, all this is handled for you in the Kubernetes environment. That's why we're using it today. We will get to doing it in Universal down the road, but today we're going to get up and running in Kubernetes very quickly. We've spent a lot of time talking about this stuff, so it sounds very like a long process to get to, but you're going to see that getting this up and running in Kubernetes is actually quite quick. And then Kuma Control. Kuma Control is our binary that lets us configure aspects of Kuma. So if I run Kuma Control, so we have a couple of different things in here. If I do a Kuma Control install, oh, oops, words are hard. They don't own us anymore. See all the things that we can install as part of Kuma Control. This is to me one of my favorite things about the approach we've taken to Kuma. And when people ask me what's the number, if I had to pick the one thing that I think Kuma does better than the other meshes in the market, it's the user experience of getting it running. I think that service mesh is universally powerful in the industry, but what we've done inside of Kuma is make it very usable and very easy to get started with. And the install is Kuma Control install control plane. When I want to bring metrics functionality in, it's Kuma Control install metrics. When I want to install a gateway, it's Kuma Control install gateway. All of these things give you, as an operator, a very quick path to getting things done in an environment. So I have a lot of appreciation for the user experience side of things. Just going to glance down at the chat real quick and see if anybody has anything to say. All right. So we're going to go Kuma Control, install control plane. Now you'll see my autocomplete kicking in there as if I've done this before. But first I'm going to run it without that. Oops, didn't mean to finish that. So you can see what this command would normally do. What this is going to do is it's going to output the configuration YAML for deploying out Kuma. So you can see the entire process that's going to go into actually deploying out Kuma from a Kubernetes standpoint. Just to be a good magician and show my environment. We're running in EKS today, so we're doing this against an EKS cluster. This is one that I had worked on for a different demo, but I just cleaned everything out of so we could do it from the ground up together. So that's an empty cluster. So we're going to do now is Kuma control install control plane. And then we're going to do a kube control apply. So we're going to take the output of Kuma control install control plane and then feed it into kube control apply. And we're going to hope that this doesn't break right out of the gate. Bunch of stuff is happening here, talking through it while that system comes online. We've created a namespace for Kuma system. That's namespace is where the Kuma control plane is going to live inside of Kubernetes. We've created a service account for the control plane process, set up the certs, set up a config map for all of the configurations. We've created a bunch of CRDs. We're very intentional about the CRDs we create. There are other meshes that create a CRD for everything. We're very intentional about making sure the CRDs that we create make sense and are usable and fit kind of the model that we're going for here. So each one of these is a policy or a component or an interaction point inside of Kuma that's very relevant to the environment. So we create a series of CRDs and we apply these configurations moving forward against the environment. This gets really interesting when we do a global deployment of Kuma. So we have a standalone and a global. A standalone is just, I'm running this as a single mesh in a single environment, where it's a single virtual machine environment or a single Kubernetes environment. A global deployment means that I'm using a Kuma control plane to interact with multiple different Kuma environments or Kong Mesh environments. A good example of this would be running that global control plane in a vSphere environment inside of your data center, but then connecting a EKS environment, an Azure environment, a GKE environment, a Linode environment, a DigitalOcean environment, and having them all act as a single service mesh between those environments. There are multiple zones, so that each one of those environments is called a zone. But they are all acting as one mesh. They know about each other. They know about each other's configurations. They know how to reach each other, assuming you've set up the right resources and communication between those. We're doing a standalone environment here today. I think if we go in and take a look at we have our control plane up. We go in and take a look at our services. We can see our services up. Now, by default, the control plane is not exposed via a load balancer. So what we're going to do is we're going to get crafty here. We're going to go control port forward and system service control plane. Got to keep switching that way. We'll let this finish loading up. All right, so that is up and running. So we can see this is a quick look into our Kuma environment. There's not much running in here right now. We're going to use this UI quite a bit to take a look at things as they deploy. We're running in standalone mode, so we only have the one zone. We have one mesh. Now, this is a pretty cool feature of Kuma that's pretty unique in how we approach it. To kind of address what this is, let's step back a little bit. Why do I service mesh? Why do I care about all this? What does this actually matter? The simplest way I explain service mesh is you're creating a platform for deploying and connecting applications better. What is better in this case? I think that by default, we're used to writing our applications to connect to other things, right? So in React, it's my favorite web front end language to write in. So in React, I use the fetch API to reach out to backend APIs. So I might fetch something like /API/health to return health data. Maybe I do /API/users to return user data, or posts to return post data. And I'm used to writing that into the application. And maybe in my app, I code that to a DNS entry or a CNAME, or I configure it to reach out to a specific static address of some sort that then distributes that out to other environments. I mean, that's like the standard application, kind of very simplified version of the application kind of deployment method. but you don't get much out of that aside from your application connectivity. Yeah, you reach your back end and life is good, but day two is always the struggle. I joke a lot that like day one we're all kind of equal, whether it's service mesh or whether it's regular applications. But day two is something none of us ever budget for and none of us ever think about, because day two is when all the complexity comes, right? So when I want to scale that environment and now suddenly I want to bring in 4 tiers of my application, that's a change that oftentimes is a whole new ball game. Service mesh makes it simpler to create more dynamic environments. It makes it simpler to bring in additional functionality. So when I want to roll out API v2, maybe the user service goes to v2 and I want to deploy out that new v2 service, I can use service mesh to gradually roll that out. I talked about that earlier in the concept of progressive delivery. I can also use traffic routing to change the routing of services between that service mesh environment. This is a task that typically would be a ticket to a network team in the past, or a manual process of some sort to get that change made. These are all things that can be self-served inside of service mesh, because what we've created is an application connectivity platform. It's something that's built for self-service from the ground up. It's something that's built to be used in CI/CD. And you can kind of see here the kind of makings of that self-service environment. I've got this meshes concept that lets me create multiple virtual service meshes inside of this infrastructure environment. I've got a default one set up right now. Maybe I could create another one. I mentioned earlier that Michael's hanging out with me. I know Victor's out in the audience helping out too. Victor works for Michael. Welcome to Kong, Victor. Excited to have you here, dude. Maybe I want Michael and Victor to have their own service meshes inside of my environment. I could create a mesh called Victor, create a mesh called Michael, and I could have them be able to access those environments. So when they apply traffic routing policies, they only apply inside of their environment. So if Michael wants to have front end talk to when front end talks to API, he wants to send API to user service, he can apply that traffic routing policy himself. Whereas Victor can maybe have the front end talk to API, but have it go to users instead, or posts instead, rather. They can apply separate policies that don't impact each other, but they can have them be part of the same global service mesh. It's a pretty powerful feature when you start to look at things like configuring independent MTLS certificates, or a different metrics configuration, or specific load balancing configurations. Service mesh is all about creating a platform for consumption. How do we consume aspects of application connectivity? How do we use this whole policy concept to drive things? And that this entire Kong Builder series is about uncovering these different policies and how to use them in a practical way. So how do we write an application and actually do something with it inside of service mesh? So let's jump into actually deploying. I don't want to go too far into the UI because there's nothing here to see yet. So I want to go ahead and deploy out my application so we can start to see what's happening here. So I'm going to switch back into my UI, or into my CLI. All right. Let's jump back into our YAML real quick without going blind from all of it, and talk a little bit about what this is going to do. First, I deploy out a config map. This is written into my application. This is not a Kuma thing, but this is all of the configuration information for my application. You can see I'm using Kuma as the mesh type here, and the Kuma system namespace. This part's very important. I'm creating a namespace called Kong. And in this namespace, I'm adding an annotation to that namespace. Annotations in Kubernetes are basically notes on a field, but we can use those notes, and many vendors do this, use these notes or these annotations to configure aspects of that environment. In this case, we're adding an annotation called kuma.io/sidecar injection enabled. What this says is any pod that's deployed, a pod being the lowest atomic value in Kubernetes, anything deployed into this namespace gets a sidecar. This means I don't have to go in and configure every one of those deployments to have one. Anything that goes in here is automatically going to get one. That sidecar is automatically going to bolt onto that application and then reach back out to the environment, or to the control plane environment. And I'll be able to show that in a few moments. So we create this namespace, and then we create a bunch of resources. I'm not going to go through all of them, But we have a front end, and what I really wanted to show was the service. So a front end and a service. This service is one of the key components of Kuma in this case, because what that does is create the reference to Kuma to understand how to communicate with this service. So that is pushed back into the control plane, and the control plane distributes this out to my environment. Again, I have a number of applications in here that are deployed. Oh, I should roll back a little bit and show this. This sets the front end service as an HTTP service. Oops, I just totally copy and pasted a bunch of stuff. So I'll go back in there. What that means is that Envoy is going to understand that this is an actual HTTP service. So it's going to gather HTTP metrics, and it's going to understand that it can do HTTP type things with this endpoint versus TCP or gRPC as an example. So this is an HTTP service. It's a web service. We're going to connect to it. So let's go ahead and deploy that so we can watch what happens. Oh, because I had that YAML written out of order, it failed when it tried to deploy out the actual config map because the namespace hadn't been created yet. So just run it a second time. So I'm going to do a Q or KGP. So I have aliases set up. Sorry to make that confusing. KGB is the equivalent of Q control get pods against the Kong namespace. Cool tip, you can go -W and it'll watch it and change it out. Now, I did this intentionally and caused an error in here. There's another step of setting up Kuma that's important. So how do we start to debug this? I talked about how we wanted this to be a builder series where we start from the ground up and we debug problems as they come up. How do we start to debug this? This gets beyond Kuma. This is like a Kubernetes question. How do I start to look at why this isn't working? I can see this front end is flapping, right? It's coming up and immediately crashing out. So let's cancel out of the watch. Take a look. We can see everything else came up fine. Let's do a kube control logs against Kong namespace and against the front end service. This is where we start to see the sidecars coming into play. So because I did the logs, I'm able to see the front end service as well as the sidecar service here. So let's go ahead and do Kong front end against front end. Host not found in upstream. My front end uses Nginx to host the actual application. So like the React style application, is hosted in Nginx. If we take a look at the application code and we go into the front end tier, we can see I do a number of reverse proxies in here to get to aspects of that environment. And I'm always using this .mesh address. By default, Kubernetes doesn't know anything about a .mesh address. That's not a standard Kubernetes thing. So what we need to do is we need to have Kuma be able to understand, what do I do with the .mesh address? Kuma has its own DNS provider that we just need to install alongside it. So we installed the Kuma control plane, but we didn't install the .mesh address as well. This functionality is changing in the upcoming release, where .mesh should be included as part of that. If not this next release, it'll be very soon after. But this is a temporary thing. So let's go in and let's do Kuma bin Kuma control install DNS. What we can see is that this configuration is pushing a new configure or an updated configuration map to the core DNS configuration. And what it's doing is it's adding in anything going to the .mesh address should go to the Kuma control plane. Again, oops. Apply f dash. Now in a few moments, that pod is going to kick out again and try to restart again. Actually, we'll gently nudge it so we can save time. Now what I've done here is I've deleted the pod. but I didn't delete the deployment. Each one of those things was deployed as a deployment. So pods are the smallest atomic unit in Kubernetes. A deployment is a collection of pods and the configurations for standardizing that pod deployment. So we can do replicas inside of a deployment and say run 4 copies of my service as an example. In this case, I deleted the pod. The deployment wants to ensure that that pod still exists. So what it does is it recreates it. Back to me. Waiting for it to come up. Still waiting for this to start resolving successfully. It should be picking up any second now. While that's still going through and figuring out how to talk in an environment, let's go ahead and take a look at what happens with the sidecar service. Let's go ahead and take a look at the Kuma sidecar. So I'm not going to break down this entire log file because there's just a lot happening here. But what you're seeing here is the communication back to the control plane. So these sidecars have registered out to the control plane. If we switch back to the UI and do a quick refresh on this environment, we can see these have all registered. They're getting their configurations. See that they're receiving updates from the environment. These total updates are the equivalent of what we're seeing in this log file here. Again, this is another thing that's consistent amongst the service meshes. If you run another service mesh and you look at the sidecar logs, you're going to see something very similar here. We've done some optimizations to ours, and there's reasons why we set it up the way we have that we believe to be the right path. But this is common troubleshooting stuff across the service mesh platforms. Understanding that relationship between a sidecar and the control plane is it's an important thing for understanding how the functionality works, but it's something that you ultimately consume. It's not something that you should necessarily need to interact with this pod. You shouldn't need to go into this pod and do any, or the sidecar at least, and do anything with it. It's just good to know that communication pathway. Ultimately, this sidecar is intercepting inbound and outbound communication, and everything that's trying to reach the actual pod that you've deployed is running through the sidecar. That's why we get to layer on things like traffic policies or encryption or the metric stuff. That's all gets layered on top because of that sidecar relationship. See if that came back up yet. All right. I was really worried for a second that that was not going to come back up and we were going to have to go way deeper in troubleshooting. So that's running now. All 4 pods are up and running. If we go back into the UI, we do a refresh. That sidecar should be online now, hopefully. Fingers crossed. Come on, little fella. You can do it. There we go. So the application's up and running, but, and this is the big but part, if I go into my services, I have no address for it. How do I get to this service now? Like this service is not reachable in the environment. I could go the Kubernetes path of doing a kubectl port forward and Kong front end, send it to 8080, go to the back end. Oops, man, wrong tabbing. And there's the app, but how do I have this set up now so that somebody else can consume it and somebody else can do something with it? Right now, it's not able to be reached by anybody. So what we're going to do is we're going to use something called Kong's Ingress Gateway, or I'm sorry, Kong's Ingress Controller, rather. Kik is an Ingress controller for Kubernetes that lets you reach services. It gives you that Kong gateway experience in a Kubernetes native way. I believe Victor is doing some really cool content on a Kong Ingress controller, so keep an eye out for that. I saw a preview of it today. It's amazing. Victor's doing great work. I'm really excited to see how that video turns out. But let's go ahead and get Kik installed. Things get a little interesting now because what we're going to do is we're going to take Kong's Ingress controller and we're going to adopt it as part of the service mesh. So this becomes effectively another application running inside of our service mesh environment. In the next version of Kuma, you'll be able to install the gateway from the command line. The framework's already there for it. So if I went in and going back to earlier when we did our install, you can see if I do that, you can see there's a gateway flag there. We have the framework set up to install that gateway. In the 1.2 release that's coming up next week, you'll be able to actually install the gateway as part of the Kuma control setup process. In this case, we're just going to apply the YAML as normal folks would. So if we do, once again, kube control get pods against Kong namespace and wait, we can see that ingress coming online. Switch back into the UI. That's all sad because I canceled the port forward, so it's still running, like it's still cached locally, but none of the services are communicating. We go into gateway. Still loading up. All right. Up and running in the environment. Awesome. Oops, I wonder if I canceled the proxying command over here. Let's redo that again. There we go. Back in the game. So let's talk about a little terminology real quick. There's a couple of terms that we've thrown out here that I haven't taken the time to step back and define yet. We've talked about gateways. We've talked about ingress, and we've obviously covered data planes, control planes. I feel like we have a pretty good understanding of that. If not, please drop a comment in the chat so that I can stop everything and we can go back and talk through that, because it's really important to understand control plane and data plane as we get into making a mesh. A gateway is an inbound way to get into service mesh. Often, probably the most popular question I get about service mesh is, do I need to spend time working on a gateway first or a service mesh first? The truth is, these are two pages of the same story, but they are different pages. The Ingress gateway, and really gateways in general, give you a point of user or service entrance into an environment. In the Kong world, our big thing is the plugin functionality that we add on top of the gateway. So we have this rich plugin market space and all of these different plugins that let you change the way that inbound traffic happens. So we add on things like OPA integration, so open policy agents. So if you want to control a little bit more fine-grained how users come in, we have rate limiting plugins, we have OIDC plugins, we have all of these plugins that modify the way user traffic comes in or impact it in some way. Service mesh is all about service to service communication. How do I make my services communicate with each other in the most optimal way while adding the most functionality on top of that without having to change my application code? Because remember, you should be able to consume a service mesh without ever changing your app code. Your app code should be able to just be loaded into a mesh and have that communication happen. And you're just getting better things out of it because of that mesh. The gateway gives you an entry into the mesh. So when we talk about service mesh specifically, and in Kuma, we have this concept of a gateway. The gateway is a special annotation that's applied to a service that tells Kuma, this is a place where users are going to come in. What that ends up doing is disabling the external Envoy listener, because remember what I said earlier about the sidecar is it intercepts inbound and outbound communication. That sidecar becomes the thing that handles all communication. So in the case of a gateway service, it said Envoy on the edge, allow this traffic in, and you only send traffic out through Envoy now. This is important when we turn on MTLS later on, when we turn on encryption, because if you have if gateway mode is not present and you try to access a service that is a service mesh service, you won't have a cert in front of it and it won't let you connect. Kong's Ingress controller automatically has that annotation applied. So by default, the Ingress controller is registered as a gateway to the environment, so it's able to be accessed externally. Ingress, on the other hand, inside of Kuma, and this is where things get a little bit confusing. Ingress inside of Kubernetes is what we're used to applying a CRD and getting a path inbound. So an Ingress resource is applied to an Ingress controller that gives you that access inbound. In Kong, we consider an ingress as a point of getting into the mesh. So when we deploy a multi-zone Kuma environment, we can deploy ingresses as well. Those ingresses live alongside that mesh environment and provide an entry point to resources that live inside of that mesh. Because we're not multi-zone, we're not deploying an ingress, so we don't have to worry about it in this case. That'll come up later. But you can see we've separated out gateways as being a different thing. Another thing I want to highlight real quick before we jump back into the application, you can see all of these tags are applied. We use tags in a really, really cool way inside of Kuma that lets you go ahead and apply policy or configuration against those tags. So I have this group demo app. I can make a traffic permission down here. I can make a traffic permission that says anything that has the group demo app tag can talk to each other, but nothing else. That lets me start to apply that zero trust, that zero trust security model where we only allow services we've defined to talk to each other. So the tag functionality is super powerful. It's something that I really love about Kuma. Note that I have like version 1 down here for these. That's for when I want to start applying traffic splitting policy. So if I want to say 75% of traffic goes to service or version 1, but 25 goes to version 2, I can do that. So at this point, should have a service up for Kong Proxy. If I hit this, it's going to fail. Why is it going to fail? Because I haven't loaded any ingress resources into this yet, so it doesn't know about it. So we will switch back into our stuff here. I'm going to go into my YAMLs folder. I have this YAML file called an entry file. What this does is it creates a service inside of Kubernetes that references the .mesh address. Why I'm doing this is I want to send inbound traffic into the service mesh, and by using the .mesh address, it will send that through the service mesh envoy instance and land it inside of the service mesh. So I want that Kong proxy, the Kong ingress controller, Kong gateway, to send that traffic into my service mesh and consume it over the service mesh. So I create that entry. Now, if I do get services again, we'll see I have a external name service here that is pointed at the front end service. Front end being the service name, as you can see down here. Kong being the namespace, which you can see here. SVC being a service, which we can see as part of kube control get service. The port it's running on, and .mesh, so we know it's going into the mesh address. I'm then going to apply standard ingress resource to point at that new service. You can see I named it front, sending it to front on port 80. Now, when I run this again, we get into our environment. So we're getting about 10 minutes out from the end of this stream, and we're on pretty good track here. What I want to do is, Taran or Michael, if you can grab this address, I will drop it into a chat somewhere. What I'll do is I'll make this really confusing and jump in here. I probably shouldn't be doing. Seeing if I could comment easily here. If it does not appear, I can. What I'm going to do real quick is, let's see, the best way to do this. Got an idea. All right, Tarna Michael, that's in our private chat. You should be able to see that on our private chat to copy in. Drop that in a way that they can click on it, or feel free to even share it on Twitter. We can have people accessing the service, and hopefully they don't crash it in the next few minutes. What this application is doing right now is it's reaching out to the different services and ensuring they're up. That's why they're green. And I've configured this application to let me have visibility into Envoy. So when I come into that front end service and I look at the Envoy clusters view, this is all of the things that Envoy is getting that tell Envoy what addresses it can communicate with. So in this environment, the database service is reachable on this address on port 5432. This is the, if you use the analogy of a brain, if Envoy is the brain, these are the neural pathways that data is going to travel to get to a thing. So we can see the database, we can see, scrolling down, we can see post service and the address of the post service in the cluster. We can see the front end service, and we can see the user service, and Redis is in there somewhere as well. This is kind of the stuff that tells Envoy how to get places. These are the metrics that get pulled out, or some of them at least, connection totals for the database. So we can see those configurations. We can see the cert configurations as well. So those are the configurations for communicating this environment. So let's kick this into gear and start playing a little bit with actually making some requests to this environment. I am not going to give everybody the logon password to this. If you guess it, it would be really fun if you went on Twitter. I don't think it's that hard to guess. So have some fun with it if you can. We can come in here. We can post a message. Like it's submitted. So those are going on. Cool. This is a functional application. All of this communication, that message I'm sending, everything is happening over the service mesh at this point. So if I dropped in every time this request goes through, it's hitting the local Envoy, and Envoy is saying, hey, what's the best path to get to this? I can start to modify this functionality and add on the traffic splitting. So if I had another version of the API, I could layer that on and start to send traffic there as well. But right now, everything is going through that actual Envoy service. So if I go into Insomnia, just for funs and grins and giggles, grab this address, I'm going to switch back to Insomnia. This is a set of APIs that I've written for that actual demo application. Oh, there's the password. So if anybody wants to go in and have fun, you can bypass the whole thing and actually just go into there and do things now. Be interesting to see what sort of messages we get. I can go in, I can create a user. So I'm going to go into here. I'm going to change this address to match the address for my app. These are environment variables inside of Insomnia. So I can just say base URL and it references that. I'm going to create a user for myself called Cody. I'll log out, log back in. Cody, Kong Strong. Oh, look, somebody has posted something. Now let's as we're starting to wrap up, let's do something that's going to break part of the environment for a quick second here and start to see kind of the foundations of how we make this stuff better. So this is right now. If I was watching the stream, my response would be, well, you haven't done much. All you've shown me is that you can continue to connect an environment together, which is true. All we've done is simulate the same functionality that you already have in your app, end-to-end connectivity. Let's start to layer on something real quick in our last few minutes together. When I go back into this this view and I go into the meshes view, we can see that MTLS is disabled and traffic permissions are set to allow all. Allow all default. Any source going to any destination is set to allow traffic right now. What happens when we delete that service or that policy? We'll go delete CRD. We'll go into traffic permissions. And we can delete the allow all default. Oops, I hit tab too many times. Now, if the allow all default is gone, oops, that's not what I wanted to do. Notice how the application is no longer working. There is no communication between those tiers now because I've turned off the default allow, so it can't talk to each other. Um, we can start to bring in policy to make that better, but first, let's also turn on encryption while we're here. I go into my individual YAML files and I go, actually, we'll go mesh policies. Take a look at the policy here. Now, this was originally set just as a MTLS policy, but I also added in the metrics views. We won't get into metrics in this view because we just don't have enough time. But if I apply this configuration, it's going to turn on MTLS, which means out of the box, there we go. Out of the box now, dot, dot, dot. Out of the box now, from day one, we now have MTLS enabled in the environment. So all of those services are automatically going to encrypt the traffic between them. So no one can sniff that traffic now. This applies to multi-zone as well. So if I was not running standalone, if I had this stretching, like I talked about earlier, between a vSphere environment, a Kubernetes or a GKE, EKS, and AKS environment. So Google, Amazon, and Azure. I think I had that backwards. All of that traffic would be encrypted end to end now because I've turned on MTLS. I've also turned on Prometheus, so it's sending traffic out or sending metrics into Prometheus, or it's trying to. Right now, it can't because I haven't deployed out the metrics install yet. It's also sending Jaeger stuff, but it can't because I haven't turned that on either. So as far as added on functionality, we now have encryption end to end. We also are applying zero trust permissions, so we're not allowing any traffic unless it's specifically allowed. So let's take a look at, I don't know what policy I have in here for traffic permissions. Let's take a look. All right, so this is the allow all default one. I thought I had another one. Guess I don't. All right. Oh, actually, here we go. Oh, well, that's not useful. All right. So we could come in here and we could, in our last minute, start to apply policies that allow this communication to happen. So for example, we could take our front end service. And if we take a look real quick at the UI, we grab the name of the service from here. So front end Kong SVC 80. Front end Kong SVC 80. Pro tip, this is not going to work. What did I do wrong in the traffic permissions? That's a weird error. Unfortunately, we don't have time to debug this one. So I'm not sure why. We'll have to return to this one and figure out why it, I know why. I know why. Because when I deleted the traffic permission before, I accidentally deleted the entire CRD. So I just need to bring the CRD back on the next stream when we will be able to actually apply the traffic permission policies. Right now, there is no traffic permission policies, so I can't apply the thing to allow it anymore. So on our next journey together, we will start to re-unpack bringing that back in. So the upstream can't communicate right now because we've deleted the traffic permission policy. So that was our opening stream, ending at 12 o'clock. In this stream, we went through and set up Kuma from the ground up. We brought in our application to it. We talked about sidecars, what they are. We talked about control plane versus data plane. We talked about what happens when you deploy an application, how to set up sidecar injection. We showed deleting accidentally the entire traffic permission policy, but we showed how we can start to enable zero trust in that way. We talked about gateways and how gateways work inside of an environment. We also enabled MTLS, so we got encryption out of the box, all inside of really about half an hour, since I spent about 30 minutes of it rambling. I hope you enjoyed this. This was a ton of fun for me. In the future, we'll start building an application from the ground up. So we'll actually spin up something in React, spin up something in Python, probably as an API. We'll connect those together, and we'll start building our own application and start bringing in service mesh policies as we build that out. The next stream is going to be next week. If you go to konghq.com/kongbuilders, that'd be great if that ended up on the stream for people to see. If you go there, you'll see all the dates of our upcoming streams. The next one's going to be on Kuma 1.2. It's going to be a really cool one. There's some really cool functionality that we're adding in 1.2, specifically some things around traffic permissions, the gateway stuff. I'm really excited to show that. We're going to do a live stream showing us actually using that stuff in probably this application as well. So tune in next week. Again, thank you to Taryn and Michael for helping me out. Thanks for Victor for being out in the audience as well. And thanks for everybody who joined. Tell your friends, subscribe on YouTube. Come hang out with us next time. Take care, everyone.